In this recording, we're going to learn a special classification of functions that's called even or odd functions. So a function is either classified as even or odd or none of the above, which we call neither. Okay? So one example of an even function would be this parabola. It has particular symmetry around the x-axis. Okay? I'm sorry, the y-axis. Okay, so it has line symmetry about the y-axis. Now, let's notice some other features. A value of a particular point, x, y, will also produce a particular point over here with the same y value, negative x, y. All right? So that is obviously related to the symmetry. So negative x has the same y value. And so if we want to determine if a function is even, here's our test. And this can be slightly tricky, so kind of take your time to understand this. If I sub in negative x into the function, for example, I've got some functions below here. If I sub in negative x for x, am I going to get the same thing as the original function? Okay. Well, the other type of classification we have is odd. So odd has 180-degree rotational symmetry. Okay, so it has 180-degree rotational symmetry about the origin here. So that means if I have a particular point here, call it x, y, like we did before, and I rotate it over to this point, now I've got negative x, negative y. So what we do is we sub in negative x for x in the function, and if it comes out to be a negative y, we know it's odd. And so up here, y stays the same when we sub in negative x. On an odd function, the y is negated when we sub in negative x. If it's neither, if it doesn't do the same thing for all x, then we call it neither. Okay, so let's evaluate a couple of these. I'll work through the first three with you so you get the pattern, and then you can try the other three. So for this first one, I'm going to evaluate f of negative x. I can look at the graph. You might be saying, well, can't you just look at the graph? Sure. Problem is, the graph can be sometimes misleading. All I need to do is slightly shift this up 1/100th of a unit, and although the graph will look like it has rotational symmetry on the origin, it in fact would not be an odd function because it would not exactly have rotational symmetry, would not have this algebraic test. So you should always use the algebra as well as visually inspecting it. So for this function, when I sub in negative x, let's see what comes out. So negative x to the third power just makes a negative, right? Negative cubed makes negative. Negative to the first is itself. Negative times negative is positive. Okay, so we look at this and we say, well, did this relate at all to this one? So we say f of negative x is equal to negative of f of x. Now right now your head might be swimming like, what? What are you talking about, all these x's and negatives? Look at it. Are all the terms opposite from what they originally were? Okay, so the x cubed become negative, the negative 7x became positive, so it's exactly opposite. So we call that odd. And if you were to have graphed it, you would see that it does have the same behavior as this graph here, where it has symmetry about the origin. Okay, example 2. We're going to do the same test. Sub in a negative x. Okay, now we evaluate. Anything to an even exponent is going to come out positive. Anything to an even exponent is going to come out positive. And the negative one is just a constant. So we look at this and we say, all right, is it the exact same thing? Well, yeah. So that means f of negative x is the same as f of x. Okay, so that means the y value for a negative is the same as the y value for a positive x. for all x, because we substituted and did it algebraically, so we call this even. Again, you could look at the graph, you would see kind of a W-shaped graph that would be symmetric about the y-axis. Finally, you might be guessing, hey, he did an odd, now he's doing an even. I wonder if this is a neither. Yeah, you'd probably be right. So let's check it out and see if in fact it is. So we've got an f of negative x. I'm going to sub it in. Okay, now just do the math. Negative cubed is always negative. 2 is just 2, it's a constant. So now we look at this. Is f of negative x equal to negative f of x? In other words, are the terms opposite? Well, one of them is, one's not. So they're not all opposite. And are all the terms the same? Is f of x equal, is f of negative x equal to f of x? Well, no, it's not the exact same, right? This first term is negated, so it doesn't pass either test. So we call that neither. Okay. So at this point, I'd like you to work out number 4, 5, and 6, and play the recording when you're ready. Hopefully you took the time to work these out. You're not just playing this recording, you're actually going to play it just to get help or to check your answer. Alright, and one thing I caught as I was working that out, I was inconsistent. I was using f of x every time. But these functions have names, right? So call them by their names. So could you fix that in your notes, please? This example in number 2 was a g of x, and the example in number 3 was an h of x. You might say, well, what's the difference? It's not the most important thing, but let's try to be as precise as we can. We can catch a mistake, we'll fix it. Alright, so these answers are as follows. The fourth function here, you want to be really careful right here. This is a source of error. The function has a negative x squared. So we do the exponent first, and then we negate it. So it's negative x squared, which is a positive x squared, and then you negate it. So that's actually the exact same thing. We call that an even. Function 5, this g of x. Okay, this one worked out to not be the exact same, nor be all opposites. We call that neither. And the last example, negative x to an odd exponent becomes negative, so that is an odd function. Thanks for watching.